What's up, math magicians? This is your boy, Mr. B, coming to you with 2.2, find slope and rate of change. Let's get right into it. There's a whole bunch of ways you can define slope. You can define slope as rise over run when you're looking at it on a graph, or change in y, or change in x. But if you want the nitty gritty, uh, points you have to plug in, it's m equals slope equals y2 minus y1 over x2 minus x1, where you have x1 and y1, x2 and y2. So that's what we have right here. There's given 2 points, and you don't need to know what it looks like on a graph, although we could. We could plot them and actually count out the squares. We're just practicing using the formula. And anytime you're going to use a formula, my first recommendation is that you write out the formula, so you know what it is you're looking at on your paper when you're doing the actual calculations and the math Excel and all that. I think my recommendation is that you write out. First of all, you label what these are. So this is x1 and y1, x2 and y2. This is a label right here, so you can don't put, because so often students put the numbers in the wrong place, and they do everything else right except they swap them. So it's really important that you firmly label and label the numbers, and then so that you can firmly in your mind understand which ones you have to put in where, because that's really tricky. The formula is this, and anytime you're using a formula, I think it's a good idea to write it out. y2 minus y1 over x2 minus x1. Again, this helps you avoid putting the numbers in the wrong place, which is a huge source of error. So we write out we label it, we write out the formula, and then we can start plugging it in. What's y2? Oh, I see it right here, it's 3. What's y1? I see it right here, it's 1. Over x2, 3, x1, 0. Make sure when you write out the formula, you also avoid the trap of putting the x's on top. That's a number. That's like a huge also source of error for students. Make sure y's go on top. But then you can simplify. Right now the subtraction is not too difficult because the numbers are all positive. It's just 3 minus 1 is 2 and 3 minus 0 is 3. Done. The slope is 2/3. Next problem, again, we've got to label it. x1, y1, x2, y2. It helps. There's no point in doing a problem quickly wrong. I'd much rather slow it down and get it right. So then, if we're going to use a formula, I got to write out the formula. y2 minus y1 over x2 minus x1. I know it's a pain with the handwriting, but actually, it's just going to make things a lot more reliable, and it's better to get a problem right for sure. Now that we have it labeled, we can see y2 is going to be 0, y1 is going to be negative 2, x2 is going to be negative 2, x1 is going to be negative 5. And notice there's also subtraction. Holy moly, look at all the negatives and the subtraction going on here. We got 0 minus a negative minus a negative. So one thing I will say is that anytime you have subtraction, maybe it's easier to change it to addition. So you're going to keep, change, flip. Keep, change, flip. Keep, change, flip. Like that. Some people just like to actually draw a line right here. So this whole symbol turns into a plus. You can do that. It becomes 0 plus positive 2. We kept the 0, we changed the subtraction to addition, and we flipped the negative to a positive 2. Keep, change, flip down here. Negative 2 plus 5. Okay, so now that it's addition, it's going to be a little bit easier. 0 plus 2 is 2. And negative 2 plus 5, well, keep this, let's see. Same signs, add and keep. Now, we've got different signs right here. This is negative and positive. Different signs subtract. So there's 5 minus 2, and then keep the sign of the bigger number is 3, and then you'll be exact. Again, this is slope of 2/3. It seems to be like the same answers we got back here, but different points. All right, next. x1, again, first step has got to be to label it. So my tip is that you write the formula, you write and label the givens, and then you keep, change, flip. So then, boom, we can see now that we have to put out the formula y2 minus y1 over x2 minus x1. And now that means we take 1, put it here, minus 4, put it here. x2 is negative 2 minus x1, which is negative 4. All right, keep, change, flip. Well, 1 minus 4, I just did negative 3. And then negative 2 minus negative 4 becomes negative 2 plus positive 4. Keep the negative 2, change the minus to plus, and the negative 4 turns into a positive 4. And then I think you can figure out what negative 2 plus 4 is. Anyway, this is going to be the slope. A skateboard ramp has a fall of 15 inches and a run of 54 inches. So you're going down this ramp. What's the slope? Well, this height right here, as I've labeled it, and what you got to do, this is an instance of a rise over run. The rise over run is going to be negative 15 because you're falling. You're going down from here down to here. And then negative 15 over 54, you can simplify that to negative 5 over 18. Let's talk about the different kinds of slopes. First, we've got a positive slope, and what that might look like is this. And the way I think about it is, I see you read these from left to right, from all the way over here to all the way over here. This biker is going up the mountain. He's got a positive slope because the rise is 4, the rise is positive 4, and the run is 2. As you can see, it's rise over run is the formula. Make sure you take every opportunity to write out a formula. Rise over run equals positive 4 over positive 2. You simplify that down to positive 2. The next kind of slope is negative. A negative slope might look like this. And reading it from left to right, you can see this skier is going downhill. How from this point to this point, the skier is going to lose 4 units of height going down. They're still going from left to right, it's going to be positive 3. So the way you calculate the rise over run is like this, negative 4 over 3. Then there's a zero slope. If this is positive and this is negative, then zero slope is basically going from left to right. You see this person's just walking along just flat surface. It's really kind of boring. The biker is going up the hill, the skier is going down the hill, but there's no hill when there's a zero slope. You're just walking along flat parking lot. The rise is actually zero rise, going from here to here. You don't go up, you don't go down. That's b0 over 5, which calculates out to 0. There's one more kind of slope, and that is an undefined slope. And this is, you might ask yourself, like, going from left to right, what is the rise and the run? And that doesn't even make sense as a question, because they're not going from left to right at all. They're just going straight down. The skier is definitely, if it were a skier or a biker, they would not be able to go up the mountain or down to the mountain at all. And the way you calculate this is you say the rise over run. The rise, in this case, should be negative 5. If it were a biker, it might be positive 5. But this is negative 5 over 0. And division, we've decided that the best way to accurately represent our reality is to say that when you're trying to divide by 0, it's impossible to produce an answer. 5 divided by 0 is undefined. It's there's lots of division problems out there where you can get a number, but this is one where you actually don't get any number. If you try and type it into a calculator, you get an error. Let me talk more about that. Let's say you had 8 cookies and 2 friends, and you want to give all the cookies out to your friends. How many cookies does each friend get? Well, you can simplify it. 8 divided by 2 is 4. 4 cookies per friend. Great. What if you had 0 cookies and 2 friends? How many cookies are your friends going to get? Well, they'll probably still be your friend, but they're not going to get any cookies. 0 divided by 2 is 0 cookies per friend. And the way I remember this is 0 over a number, 0 over n is on. That's fine. Party on. You can get a number. The number is 0. But where division breaks down and can't produce an answer was if you have 2 cookies and you got no friends. Well, first of all, if you have no friends, talk to me. We'll hook you up. Everyone needs a friend group. But if you literally have 0 friends, then you got a big problem, because you got your 2 cookies in your hand and you can't give them to any friends. How many cookies per friend does everybody get? The question doesn't even make sense, because you have no friends. And so what do you do with your 2 cookies? You can't produce a number to say how many cookies each friend should get, how many cookies per friend. The way I remember this is any number over 0, no, you cannot produce an answer. We say that this is undefined. And this is not a problem with division. This is how we want it to be. We want there to be no answer to this division problem. You say it's undefined. Here, anytime you're comparing slopes, one way that they might compare is they might be parallel. Parallel lines are lines in the same plane that never intersect. So, for example, if you were to graph y equals 3x and y equals 3x minus 5, notice they have an equal slope. They both have the slope of 3. You graph them, and this is what it looks like. And then you've got those train tracks. It's parallel. You can follow that graph up and down forever, and they'll never intersect. That's because they have an equal slope. So that's easy to spot. What's a bit trickier to spot is perpendicular lines. Perpendicular are lines that intersect at 90 degrees. So, for example, you might see something like y equals 3x and y equals negative 1/3 x plus 1. So, you can see here, let me give you an example of perpendicular slopes. So a slope of 2/3 and a slope of negative 3/2, those are perpendicular. Another example, negative 5/6 and positive 6/5. You might notice there are two different things that these have in common. First of all, one is positive, one is negative. You can see here, one is positive, one is negative. They're opposites of each other, opposite. And then the fraction form of these is flipped. So you can see 2/3, 3/1, 5/6, 6/5. Here, 4/5 and negative 4/5, you might be tempted to say that these are perpendicular, but they're not. Although you do have one of the two conditions, this is positive and this is negative, they're not also flipped. They've got to be reciprocals as well. And here, oh, wait, these are reciprocals, 7/8 and 8/7, but they're not perpendicular because one of them has got to be positive and one of them has got to be negative. Here's what that might look like. I'm graphing y equals 3x right here. Boom. Y equals negative 1/3 x plus 1 here. And they do intersect at perpendicular lines. Going back to our original over here, it's actually, I'm going to say this is, you can see these 2 points. If you actually graph these and connect them, they'll produce a slope of 2/3, and so will this. So the lines that connect these two, and the line that connects these 2 points, and the single line that connects these 2 points, if you graph both of those, you'll see that they're parallel to each other. I'm going to reveal this for a second anyway. I don't care. It's fine. Here, 2/3 and negative 3/2, this one's positive, one's negative, and then they are reciprocals of each other. 2/3, negative 3/2. So they're flipped. And then last thing over here, I just want to show you, if you were to graph these, y equals 2 and x equals 4, y equals negative 3, we've got some parallel lines going on. Y equals 2, y equals negative 3, those are also parallel. They have a slope of 0, and a slope of 0 and a slope and an undefined slope. Those are also going to intersect at 90 degrees. I wanted to say that I come from a family of runners, so I run all the time. I'm the black sheep in my family. I'm kind of like the misfit who's only run one marathon, and I did it back in 2009. That's your audio check, and I'll see you in class. Take care.